Okay, hello students. I hope you all are well, and please, during these tough times, as I posted you in the WhatsApp group, please stay indoors and do follow all the guidelines which have been issued by the local authorities, and it's been displayed 24/7 in TV channels. So do ask your parents as well to follow those guidelines, and please be safe. These are really tough times, and as a responsible citizen, we need to follow those guidelines. So nothing new. I mean, you need to stay indoors. That's the only way we can prevent the coronavirus from spreading. And keep hygiene. Wash your hands very frequently, and do ask your elder brothers, sisters, youngsters, and your parents to please follow the guidelines. But as you're aware, I mean, life needs to go on. We need to start with the curriculum because we are losing on precious time, isn't it? So let's start with the first unit. I mean, as I promised, I'll be sending you these videos for half an hour duration from Monday onwards, right? So sticking to my commitments, so we'll start with the physics curriculum. So first and foremost, best wishes for the new session. I hope you all will struggle real hard and you will study consistently. I mean, the day I post this video in the group, you need to hear it, you need to follow the instructions, you need to concentrate on your self-study, and in case you have got any doubt, you can just ring me anytime. I'm available 24/7. So please, you need to be consistent. If I'm making an effort, you need to reciprocate that, right? So anyway, without wasting any further time, let's start with the first unit. So basically there are no relations in the syllabus of +1 and +2 physics. I mean, only 5 to 10%. As I've told you, while solving numericals, you need to have a clear concept of laws of vector addition, how the two vectors are added vectorially using laws of triangle law of vector addition or parallelogram law of vector addition. Now all the results, right? And in the waves chapter, that is also related to +2 as well. Anyway, that's in the second part. So anyway, let's start with the first unit, and that's electrostatics. Now as you can see, electrostatics, it involves two terms. Electro, something dealing with electricity. Statics, we all are aware, it is related to stationary or rest. So electrostatics basically is a branch of physics that deals with the study of electric charges which are at rest. So throughout the unit, we'll be dealing with those topics which are related to study of electric charges at rest, right? So there are 5 chapters in this particular unit. So we'll first start with Coulomb's law. We have done it in +1, gravitational force, isn't it? Gravitational force that's applicable between any two material bodies. Here we'll be dealing with electrostatic force, which will be present between two charged bodies. So before we deal with Coulomb's law, we need to concentrate on this particular term, charge. It's a very frequently used term. You must have studied this term, or you must be knowing about this term right from your junior classes, isn't it? So let's start with charge, very basic concept. You've heard about positive charge, negative charge. Bodies are neutral, means net charge is 0, isn't it? And you're aware of the basic components or basic elementary particles which a body is made of. Every body is made up of atoms and molecules. An atom, it comprises of a central positive core known as nucleus, surrounded by a cloud of electrons. So protons, neutrons, these are the constituent particles of nucleus. Proton is positive charge, electron is negative charge, neutrons are electrically neutral. So these all are charged bodies. Neutrons, that's electrically neutral, that's a component of nucleus. So what charge is actually about? I mean, how do you define a charge? It's not a process, it's not a phenomenon, it's basically a property. and that too it's a fundamental property. It's a fundamental property which are possessed by few elementary particles. Few, mark my word, few elementary particles, by virtue of which they exert upon each other an electric force. And the nature of that electric force may be either attractive or repulsive, depending upon the charges under consideration. So again, I'm repeating, charge is a fundamental property which is possessed by few elementary particles like protons, electrons, not neutrons. So I've stated few elementary particles, by virtue of which they tend to exert an electric force upon each other. And obviously, that electric force may be either attractive or repulsive. Like charges, we all are aware, they will tend to repel each other, while unlike charges, they will tend to attract each other. So I think definition of charge is clear, isn't it? So it is a fundamental property possessed by few elementary particles, by virtue of which they exert upon an electric force of attraction or repulsion, depending upon the nature of the charges. Now, normally all the bodies are made up of atoms and molecules, and an atom is electrically neutral because atom is composed of positive charge as well as negative charge. The total number of protons inside an atom, normal atom, is exactly equal to the total number of electrons surrounding it. Now what happens is, protons, as we are all aware, it is positive charge, plus 1.6 into 10 raised to minus 19 coulomb. An electron carries charge of minus 1.6 into 10 raised to minus 19 coulomb. So when the number of protons is equal to the number of electrons in a normal atom, then the atom is electrically neutral. So net charge on a normal atom is 0. So since bodies are made up of atoms and molecules, so net charge on any given body, normal body, without electrification is 0. So how to charge a body? How to electrify a body? So there are various processes here. That is what we are going to discuss right now. So electrification or charging of bodies can be done by three processes. One is by friction, second one is by conduction, and the third one is by induction. So charging by friction, charging by conduction, charging by induction. We'll deal with these topics one by one, right? So let's start with charging by friction. Charging by friction. Again, we all are aware of this term friction. This term friction comes into existence whenever the two bodies are rubbed against each other. Now what happens is, these are the two neutral bodies, right? When we rub these two bodies against each other, then it might happen that electrons from one body get transferred to the other body. So what is happening is that earlier this body was neutral, this body was also neutral, both the bodies were electrically neutral, but due to the transference of electrons from one body to the other, now this body will have excess of electrons while this body will have deficiency of electrons. So the body which loses electrons or which now has deficiency of electrons will acquire a net positive charge, while the body that is gaining electrons, that will acquire a net negative charge. So two neutral bodies, if they are rubbed against each other, then due to the transference of electrons from one body to another, both the bodies get electrified, equal and opposite charge. Both the bodies will develop equal and opposite charge. The body that loses electrons will tend to acquire a net positive charge, while the body that gains electrons will acquire a net negative charge. So this is known as charging by friction. It's very simple. So friction, rubbing the two bodies against each other. That's the process by which, due to transference of electrons, both the bodies get electrified or charged. Positive charge means deficiency of electrons. Negative charge means